Welcome back to my YouTube channel. I hope you're doing well. Today I will be focusing on strength of material N6. Okay, we have given question 1 says defined uh, direct stress. Defined what is a direct stress. Actually, we must know what is the direct stress. The direct stress supposed to find out direct stress. Define that. How can you define that? This is a, we know that this is a load, isn't it? Applied, it's a load applied per unit uh per unit cross section. Oh yes, I can see per unit cross section, right? Per unit cross sectional, you can say per unit cross sectional area. All right. Then that resist the change in size. This is our direct stress. It's a load applied per unit cross-sectional area that resists the change in size. That is a direct stress. This is how you can define the direct stress. All right. So we're given 1.2, read as follow. A steel rod shown in figure 1 below has the length, we've given the total length. The steel rod has a length of 61 and the diameter of 50,8, where here it is of 50,8. Right, then what else? A center hole, it has a hole. This is a hole there, got the hole there. Then that hole, it has a diameter of 25.4 millimeter drilled. We have our diameter millimeter drilled is drilled from one end for to a depth of 10.16 centimeter. To a depth, here is our depth that we are talking about. To that depth, a compressive force of 200 kilonewton is applied to the rod. That is a compressive. Then says take Young modulus of elasticity to be 200 gigapascal. So we've given says there calculate 2.1.1 says calculate the stress in the hollow part. In the hollow part, we are focusing on this, the stress in this part, guys, in the hollow part, the stress in that part, in the hollow part, guys. You want the stress in the hollow part. So if you until the stress there in the hollow part, we're focusing there. All right, as you can see, guys, then we want the stress. By the way, the stress there to 1.1, like that. The stress in the hollow part, I can say F1. The stress is force over area. All right, stress is force over what? Over area. We have given the force, which is 200 kilonewton times 10 to the power of 6. Area will be pi over 4. Remember, because this is the diameter, that is the one to in the hollow part. Then we'll subtract the outer diameter, subtract the inner diameter. So they will have our cross section to be 0,0508. Then do not forget to square that. Then we subtract the inner one, which is 0.0254. Then we square this, right? Then the stress there, remember what will be the stress will be 131,568 will be in megapascal. All right, in megapascal. And this is what we'll have there in megapascal. So what else do we need? We have now 1.2.2 should determine, what are we supposed to determine? The stress in the solid part. Here it's our solid part, guys. So solid part, we know the stress. I can call it stress 2 will be the force, but area 2, the area of the solid part, the stress is still, the force is still 2000 times 10 to the power of 3 divided by what? The area. It's pi over 4. But now remember, this solid part is this. We'll focus on this whole diameter. We'll take the whole diameter now. We'll take the whole diameter, which is the whole diameter is 0.0508 squared. Then our area there, then our stress, then the solid shaft in the solid part will be equals to 98,676 megapascal if you punched your calculator accurately. Then says now determine the total change in what? In length. The total change in length. All right, so we want the total change in length. Xt, remember now, will be x of the first part, changing the length of the first part plus the change in length of the second part. Remember this, guys, it's a series bar. We have this, remember, two lengths then. So this is the series, a place in series. So if I place in series, this is what we'll have. So we know that x, guys, I will take out the common fact because Young modulus is the same. Check here, we have Young modulus of 200 gigapascal, the same. So I may, okay, let me just write it. We know this x, that x change in length is force multiplied by length 1 over area 1 multiplied by Young modulus of elasticity plus F multiplied by length 2 divided by area 2 multiplied by Young modulus of elasticity. So I will take out, I will take these two as a common factor. As you can see, they are common. So this will be F over E into L1 over area 1 plus L2 over L area 2. So this is what we have. The force, it was 200 times 10 to the power of 6. The modulus was 200 gigapascal times 10 to the power of 9. So what is the length of the first path? The length here is the length of the first part there. We have the length of the first part there, as you can see. All right, 50,84. You'll times that, will multiply by, will be times 10 to the power of what? Of minus 3. All right, so you can That is our what? Our length there. That is the length will be. Yeah, if you take the calculator, you will have what there will be 50 comma that I want to convert that length. Let's try and convert that length, comma 8 times 10 to the power of minus 2. We'll have this to become, that length will be 0 comma 5084. All right, divide this by the area, which is pi over 4, by the diameter. The first part is this one. The area now will be the hollow part. We'll consider the hollow part. Okay, sorry. No, guys. I have used this. That not. Or I have used that length. So that length cannot be a hollow part. The length with the hollow part is this one. All right. So that length cannot be with the hollow part. So that is the length we're supposed to use there. That has no hollow part. As you can see, there is no hollow section here. The hollow section is for that length. So what will be the area? The area will take the diameter 50,8. Then divide by 100. This will be 0, 0.05 508 squared. All right, this is what we have, plus now the length 2, what is L2, 10.6 centimeter, which is the same as that is typically same as what? Same as 0, 1016. Divide this into the cross section, pi over 4 into 0.0508 squared minus, remember this is a hollow part now, it's a hollow section, minus that, subtracting them, minus 0.0254 squared. Then if you punch this, we'll get that total extension to become 0.3178 millimeter. Let me double check my wax. What do we have there? May I quickly double check? We have 200 times 10 to the power of sorry, you see there, the force is time, it is kilonewtons, so you see my mistake here must be 3. Yes, times 10 to the power of 3 divided by 200 times 10 to the power of 9 into 0, 0 or 0.5084 divided by pi over 4 into 0.08 or 0.508 squared plus 0,106 divided by pi over 4 into 0,0508 squared minus 0,0 do like that. Yeah, this is what we have. Then we have now question 1.2.4, final length of the rod. We want the final length. The final length of the rod. We're talking about length final. We want the final length. Okay, you can say final length would become to its initial length plus the change in length but final length plus the change in length, but just what the total change in length there. Remember, total extension, change in length, initial length, it was we've given to be 61 centimeter, as length of 61 centimeter. Okay, we have 61 centimeter, they said that, plus, that is in centimeter, this is in millimeter, so there must be a change. Okay, this I can convert this to become in meter. I will multiply this by 10 times 10 to the power of minus 2. This will be in meter. Then I add this, convert that to be in millimeter, times 10 to the power of remember, one day change in length where the final length of the rod, yes, times 10 to the power of minus 3, so that this must be in meter. Also the SI units must be the same. Then I add there 61 times 10 to the power of minus 2 plus 0,3178 times 10 to the power of minus 3. This will simply equals to millimeter will be 610,3178 millimeter. This is what we have. So guys, this is what it is. So thank you for watching. Sorry about that. Thank you for watching. May you kindly subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. Feel free to comment and share this to your fellow classmates.